So good morning, students. Good morning, students. So in this session, we are going to discuss about one of the important topic called storage classes in C programming. Okay, storage classes. The one thing that you have to know before understanding storage class is data types. Okay, so you all know the basic data types or primitive data types like int, float, char, long, double, void, etc. Okay, so the storage class is a topic where we are going to predominantly deal about the placement of these data types and their effects. Like you all know that predominantly there are two different types of place where we can use a variable. One is called a local variable, another one is called a global variable. So you all know that for the local variable the visibility is only inside the function, and for the global variable it is for the entire program, right? So based on these ideas, we are going to discuss a topic called storage classes, where we are going to deal about four important classes. Okay, four important classes. They are auto, extern, static, and register. Okay, I repeat, there are four important classes called auto, extern, static, and register. We are going to deal about these four things in detail. Okay, we are going to deal about the four things in detail, right? Okay, so let us first start with how to declare these things. Okay, declaration of storage classes. Okay, so the declaration is simply like a normal variable declaration. So like a normal variable declaration plus the storage class keyword. Okay, plus the storage class keyword. This is the most important thing. Okay, so let me tell one example for each and every type. Okay, suppose if you for a normal variable declaration you will be using like int a comma b comma c, and if you are using auto you have to put auto in front of it. Okay, so this is first one. Suppose if you are declaring some float variable like root1, root2, and you want to make it as a extern variable, then you have to put a keyword extern in front of it. Okay, and you want to create one int variable called count, and you want to initialize it with 0, and you want to make it as a static, put the keyword static in front of it. And if you want to make one more variable count 1, okay, and you want to use a register storage class, put register in front of it. That's all. Very simple idea. The declaration is very simple. Okay, this part you all know, normal variable declaration. This part is normal variable declaration. Okay, and in addition to that, in front of it you are specifying the storage classes. Right? That's all. Okay, I hope this idea is clear. Okay, now we are going to see the different type of storage class one by one. starting from auto, extern, static, register, one by one with a neat example I will tell. Okay, so before entering into that, you must know the following things. If you know the following things, then the idea will be very simple. That is nothing but function prototype. Okay, function prototype. So already we have discussed a lot in the class about it. It contains three parts. Okay, function declaration, function definition, and function call. Okay, so just I will revise it. Okay, no problem. So function declaration, you are telling to the compiler that I am going to use this function. And function definition, you are telling the process that is taking place with respect to the function, the set of lines of code that is working with respect to the function. Function call, the place where you want to use the function. Okay, so these are all the three different things with respect to function prototype. I hope you all are clear with this. So if you know these things, then the four different type of storage classes is very easy. Okay, why I am saying this is because storage class we are going to discuss with respect to function only. So if you are good with the function, then the storage class will take very less time to understand. Okay, so now I believe that you all are good with these three concepts, and based on that I will tell the rest of the things. Okay, so first we will start with auto storage class. Okay, so this is a default storage class. Okay, when no storage class is given, default storage class, that means when no storage class is given, the compiler will automatically consider it as auto. Like simply I am giving int a comma b, I am not giving anything in the front. By default it will consider it as auto. That is called default storage class, right? So the scope of this function, the scope where you can use this auto means only inside the function. The moment I am saying only inside the function, you must understand this is local, not global. Okay, this is local. Okay, so the second one, suppose if you are having three functions, and every function is having a variable m is present in all the three functions, then all three m's are independent of one another. That means there is no connection. All three m's are independent of one another means there is no connection among these three m's, because the first m will be present under function 1, second m will be present under function 2, and third m will be present under function 3. So there is no connection among these three m. This you should be very clear. Okay, and once we are saying the local value will not be retained. Outside the function. This you all know, right? Outside the function. So the lifetime of the value is only inside the function. Okay, so when you are coming out of function, value will be vanished. It will not be available. Value will be vanished. Adu maranjirum. It will not be available. Okay, suppose if I am giving int a comma b, and I am not initializing, then what will happen? For a and b, then garbage value will be allocated. That means some random value will be allocated for A and B with respect to R2, right? So only one important thing that you have to keep in mind is this is very similar to a local variable. When you are using the same variable name under different function, each and every variable name is separate and they are not having their life outside the function. If we are not initializing them, garbage value will be initialized. That's all. I am going to tell one beautiful program now. If you understand this program, then it will be very easy. Listen carefully to the program. I will write the entire code now. Okay, step by step we will understand this example. Okay, so void function 1 of void, that means no list of parameters, right? So void function 2 of void, here also no list of parameters. So just think about this particular part, the syntax, that is called return type function name list of parameters semicolon, return type function name list of parameters semicolon. This comes under function declaration, and after function declaration only the main function will come, right? So now void main. Okay, so inside void main, okay, I am using int m is equal to 1000. I am declaring one variable m and initializing it with 1000, and then I am using one line called function 2 of, okay, and then I am using printf %d /n comma m. I am closing the main function. Okay, so what you are able to observe here in this line, I does not have return type. I have only function name list of parameters and semicolon. This is nothing but function call, right? So that is why I am asking you to read the function related things before understanding this program. If you are good at function, then you will understand this in seconds, not a problem, right? So next one, I am going to define one more function called void function 1 of int m is equal to 10, okay, print f %d /n comma m. Okay, I am closing this. Okay, the moment you see this, you are able to understand that this particular part, void, that is return type function name list of parameters semicolon not present, but you are opening and closing, then you are able to understand this is nothing but function definition, right? So listen carefully now. Void function 2 of, okay, inside that I am giving int m is equal to 100, function 1 of printf %d /n comma m. I am closing it, and here you are able to understand that this particular thing is return type function name list of parameters, and then you are opening the brace, then it is called function definition, and you are entering into this, and here you are seeing no return type function name list of parameters semicolon, no return type, then it is called function call. Now if you observe, previously I have told that one variable that is present in 3 different functions. If you observe here, int m is equal to 1000, the scope of this particular thing is only inside the main function, because it is present inside the main function. So the value m equal to 1000 will be available only inside the main function. Clear? Now the moment you are coming into function 1, you are declaring int m equal to 10. The scope of m equal to 10 only inside function 1. Okay, and here you are entering into void function 2 and you are giving m equal to 100, and the scope of m equal to 100 is only inside function 2. Clear? Clear? You are having 3 variables. That 3 variables are present in 3 different functions. So the lifetime of the variable is only inside that particular function, right? So now we will try to execute the program. Okay, so what will happen when you are executing this program? You are compiling the program. So first the compiler will see the main function. You are entering into that. Currently inside main function, you will be having 1m and the value will be 1000. Inside function 1 you will be having 1m and the value will be 10, and inside function 2 you will be having 1m and the value is 100. This is the idea, right? Okay, so now you are telling that m equal to 1000 and you are calling the function 2. You are calling function 2, so the control will be transferred over here, and here you are entering into this and you are telling that into m equal to 100. Okay, and then you are telling that you are calling the function 1. So the control will be moving from that place to this place. Okay, you are calling the function 1, so the control will be coming to over here, and you are telling that int m equal to 10, and then you are printing the m. Okay, now you are telling int m equal to 10, so this particular thing will be triggered and you are printing. So when you are printing this, then the value output you will be getting is 10. Why 10? Because you are currently under function 1. Under function 1 the value of m is 10. Okay, after printing that, the control will be again moving back to this particular place. Now you are under function 2, and you are printing m. The value of m under function 2 is 100, so the value will be 100 will be printed. Okay, so you are calling, initially you are getting a call from here, you are getting into function 2, and then inside function 2 you are calling the function 1 and you are coming here and you are printing this and going back to function 2. Now from where you got the call for function 2? You got the call from void main, right? So after executing this line, you are going back to the void main, and there you are having one printf where you are printing m. Inside void main the value of m is 1000, so the value you are going to get printed is 1000. This is the idea. Clear now? So automatic variable is one in which you are going to have the scope of the variable only inside that particular function. Okay, even when we are moving from one function to another, the value will not change. That function value will be retained. That value will only be printed. Okay, so again I will erase this control and I will tell one more time. Okay, how this value output you are getting, one time I will tell, because you might get confused in that, right? So first you are calling the function 2, so the control will be passed over here and function 2 will be called, and the value you are initializing is m equal to 100, and then again you are calling the function 1, so the control will be transferred over here. Okay, control will be transferred over here. Now you are calling the function 1 and you are making m equal to 10 and you are printing m. Here m equal to 10, so the output will be 10. And after completing this, you are going back to the function 2 where you are printing m. Currently the value of m over here is 100, so you will be printing 100. And after completing this, you have to go back to this particular place. So the control will be transferred to this place where the value of m is 1000. The 1000 will be printed. That's all. So this is about the automatic variable or automatic storage class. Now I will take you to the external variable or global variable. Very, very simple idea. If you are clear with auto, then global will be very, very simple. Okay. So the second one is global variable or external variable. Global variable or external variable. So if you observe clearly, you will understand this external is nothing but external variable. Okay, external variable or global variable. Okay. So here it is not limited to single function. So the scope is entire program. The scope is entire program. Okay. So if you are assigning value for global variable in one function, it will be retained to other function also. This is a very important point. Previously in auto, the value of m will be retained only inside the function. When the moment you are going out, the m value will be changed to 100, the m value will be changed to 1000, but it is not the case. It will be same under global. The assigned value for global variable in one function, it will be retained in other function also. This is a very important point. Okay, suppose if initial values not given, previously in auto it is considered as a garbage value. Here it is initialized to initial value not given, it is initialized to 0. This is a global variable. So it is not limited to one function. The scope is entire program, and if you are not assigning any value, it will be initialized to 0. That's all, very simple, right? So now we will see one interesting program with respect to global. Okay, example. Listen carefully to the example. Int function 1 of void, int function 2 of void, int function 3 of void. Okay, int x, and then I am having int name. Okay, from this you are able to observe that all these things are above main function, so these are called global. Global declaration, and in particular these three things are function declaration. So now in particular I want to say that x is above void main, so I can conclude this is a global variable or extern variable. And we are not initializing any value to x, we are simply declaring x. So what will be the value of x? Now? 0. The value of x will be 0. I hope it is clear now, right? So now I am proceeding forward. So listen carefully now. So x equal to 10. I am telling inside this function, I am telling x equal to 10. Now this is called global initialization. Okay, because here I am declaring it, here I am changing the value of x equal to 10. So the x value will become 10 now. Right? So printf %d/n x, again a printf x equal to %d comma, I am making a function call, function 1 of, this is the function call, right? Because function name list of parameters. Okay, so again printf x equal to %d comma fun2 of. So this is function 2, calling the function 2 and printing the result. Printf x equal to %d comma, so you add the slash in here because the output will not come in the next line. Function 3 of, okay, you are just return 0 and you are simply closing it, right? So what is happening here? I am just printing the value of x here, and then I am calling the function 1, calling the function 2, calling the function 3. Okay, so let's write the complete code and then we will discuss the output. Okay, so let us define the functions. Int function 1 of, okay, x is equal to x plus 10, return of x, and then int function 2 of int x is equal to 1, return of x int function 3 of x is equal to x plus 10. Okay, that's all. Okay, so now we will trace the output. What will happen now? Initially, the compiler will see the main function and see that x equal to 10. Yes, it is declared in a global section and x equal to 10 printf. So the output you are going to get is 10. Obviously, here the output will be 10. And then printf, you are calling the function 1. So the control will be going to this place. And here you are not declaring any x, you are just adding the value of x with 10. So previously the value of x is 10, so 10 plus 10, the answer will be 20 here, the x value will be 20 here, and the value will be returned. So printf x equal to, so now the x equal to 20 will be printed. Okay, listen carefully. One second, just to give you a more interesting idea about it. Okay, so far here you are declaring x. Okay, so x initially it will be 0 as you are not giving any value. The moment I am giving x equal to 10, this value will become 10, right? And I am printing x, so the value of x will be 10 here initially, and then printf x equal to percentage function 1. I am calling this function and I am adding 10 with the x. So initially the x is having 10 and I am adding 10 to that and I am saving the result to this. So the x value will become 20 now. The x value will become 20 now, and I am returning x, so I will be coming back here. And then I am calling the function 2. Here I am calling, and the moment you see here, I am giving int x. So this is local. Why? Because I am declaring one variable. So one box will be created. The name of the box will be x, and the value I am giving is 1, and I am returning x. So when I am coming back with this, now the value of x is equal to 1. Okay, why you are getting the x is equal to 1? Because I am declaring one x here. I am not using the global variable. I am declaring it and I am initializing it with 1. So this is nothing but an example for auto again. Okay, and then function 3. You are coming back to the function 3, and what you are doing here, x equal to x plus 10. Already what is the value of x? You are not declaring here. You are simply using the x. Already what is the value of x here? 20. So you are making 20 plus 10 and you are assigning it to x again. So the x value will become 30. X value will become 30 and you are printing it. Now the x value will become 30. Okay. Okay. So if you clearly observe, the first output, second output and third output, these three things are using global variable. And when you are having x equal to 1, it uses the local variable. Okay, it uses the local. Why? Because the scope is only inside the function. You are declaring it here and using it here. This is called external or global variable. Okay, right. I am taking you forward now. The third one is called static variable. Okay, so far what you know, if I give auto, scope is only inside. Okay, if I give extern, okay, scope is outside also. Okay, and whenever we are giving static, okay, the value is retained. Throughout the program, even it is initialized again. That is a very important point, because according to function 2 in previous program, scope is outside also, but if you reinitialize, it becomes auto, right? It becomes auto, right? See the example here. Okay, so in function 2 I am giving int x again. I am I'm just redeclaring it. Then one box will be created and x value will become 1 here. This is the problem with respect to global variable. But even though if I am using like this, the value should not change. If that is the condition, even I will use int x again and again wherever I am using. Okay, but value should not change. Then you have to go for static. Okay, the value is retained throughout the program, even it is reinitialized again. Okay, okay. So according to this, function will retain the value. This is a most important word permanently. Function will retain the value permanently. Okay, okay. So there are some simple rules that we have to follow for a static variable. Okay, so the first one, the initial value must be constant. The initial value must be constant. Second one, the initial values should be assigned to the static variable. Initial values should be assigned to the static variables. If initial values not given, then 0 will be assigned. If initial value not given, then 0 will be assigned. This is there. Clear? So you will understand it very clear manner with the following example program. Okay, so listen carefully to the example program. Very small program, simple program. Listen carefully. Void stat of void, void stat of void, and then you are having a main function. The moment you see this line, you will understand this is nothing but function declaration. This is nothing but function declaration, right? Int main, and then you are declaring a variable int I for I is equal to 1, I less than or equal to 3, I plus plus. So inside that you are calling one function called stat. Okay, so this is nothing but function call, and then you are having return 0, you are closing, right? So far what you are having one function declaration step, and inside that your main function you are declaring one variable I, and then this I variable you are using for loop, and you are calling the functions. How many times you are calling the functions? First time you will be calling when I equal to 2, you will be calling when I equal to 3, you will be calling when I equal to 4, the condition is false, you are getting out. So 3 times you are going to call the functions 3 times, right? So now we will see the function definition part. Okay, so void stat of, inside that you are giving static int x equal to 0. You are telling that static int x equal to 0, and then you are telling x is equal to x plus 1. Okay, printf percentage d, let's say printf x equal to percentage d slash n, okay, comma x. Let us close this, right? Okay, so very simple idea. Listen it carefully, you will easily understand it. So the control will see the main function, it will see the variable I, and then it will see the for loop. So it is going to call the function stat for 3 times. So it is calling for the first time, and you are declaring a variable x with the value 0, and you are using the static keyword. So when I'm using the static keyword, value change will reflect. Value change will reflect. That is the idea, right? Value change will reflect. So you are having x and the value will be 0, and then you are making x equal to x plus 1. So 0 plus 1, the x value will become 1 now, and you are printing the x. So the output you are going to get is x is equal to 1 first. Okay, and then you are going back. After this, you are going back to this particular thing. For the second time, you will be calling. Okay, and again you are reinitializing x equal to 0, but it will not reflect. That is called the purpose of static. Okay, even though I am giving int x equal to 0, it will consider the previous value 1. So already x value is 1, so x plus 1. Now the value will become 2. So you are printing the value you will get is 2, right? And then you are calling it for the third time. And you are again reinitializing with x equal to 0, but it will not reflect. Already I have given the keyword static, so the x value will be incremented. It will be 3. Now you will be getting x equal to 3. Okay, x equal to 3. This is the idea, and you are going to coming out of the loop. That's all. So whenever you are using the static, the variable contains the value that is available permanent. Even you are reinitializing, that value is permanent and it is changing. Okay, one interesting thing I will tell now. Suppose if you are not using the static keyword, then what will happen? First time you will be calling x equal to 0, x equal to x plus 1. So you will be printing x equal to 1. Second time you will be calling, it is reinitialized to 0. Then you will be getting x equal to 1. Third time you are calling x equal to x plus 1, 0 plus 1, x equal to 1. Okay. So this is like auto. Because the value of x equal to 0 is present inside one function that is local. Then you will be getting x equal to 1, x equal to 1, x equal to 1. But the moment you are using the keyword static, you are getting a different output. That's all. The value will not change because it is permanent. That is a keyword you should understand with respect to static, right? Finally, I will take you to the register variable. Okay, so no program for this because it is very simple concept. Okay, so the register variable, okay, it tells the compiler you are going to store value not in memory but directly in register. Okay, so when you are directly storing the value in register, it is like a cache memory. So you can access it very fast. This is the only purpose of the register variable. Okay. So but the register, the quantity will be very less. Okay, like 6 boxes will be available. The moment the 6 box got filled, it will be directly converted into automatic variable. Okay, so you all know that the cache memory is not that much big. So the register is used once when you want to access something very fast, but it is not quite oftenly used. That's all about register memory, right? So now I will give one table. That is the end of this topic. Okay, this is a very important table. Based on your understanding, you can answer these questions, right? Okay, so I strongly recommend you to revise the concept. Okay, after revise this concept, please again play this video and come to this particular part. Then you will understand it better. Serial number, storage, declaration area, visibility, and lifetime. Okay, so we are going to discuss this for all the things one by one. First we will deal with auto. So where auto will be declared, okay, please pause the video, revise the things, and then come back to this part. It is kind of revision. Okay, so where you will be declaring auto, it will be a global area or inside a function. It will be definitely inside a function. So when you are declaring something inside the function, what about the visibility? That is also inside a function. What about the lifetime of the variable? That is local, only inside the function. Only inside the function. I hope it is clear. This is for R2. Okay. The next one is static. Sorry, next one is external. What about the declaration area? Whether it be declared inside or above all the functions, it will be declared above all functions. Or it will be in a global area. Next, where it will be the visibility, it is visible entirely, entire program. The visibility will be entire program, and the lifetime is global. The next one, third one is static, and we see one example where the declaration area is inside a function, okay, and visibility is only inside the function, but the lifetime is, the value of x is not changing throughout the program, so the lifetime is global, because the value of x you get is 1, 2, 3, because the lifetime is global. And then the last one is a register. It is declared inside a function. It is again, visibility is inside a function, and the lifetime is local. So it is similar to, very similar to R2. It is very similar to R2. Okay. So this is a very, very important question. Please do revise it. Please do study it, make a notes, and then go to exam. All the very best.